So, so I'd like to welcome everyone to this SAT prep session for the Math with Calculator portion of the SAT. And I would like to briefly introduce myself for those who haven't been to these meetings before. My name is George, and I am one of the University of Chicago interns at the Education USA Mexico City Center. Although I am not actually physically there right now, I'm working remotely from home. And now I'll let my fellow intern here, Danielle, introduce herself, who is actually working at the center.
Hi, everyone. So as most of you probably already know, my name is Danielle. I'm one of the University of Chicago interns here at the Education USA Mexico City Center in Mexico City. So it's really nice to see a lot of you again. I'm not sure what happened to my camera. There we go. It's really nice to see you all again. And yeah, really excited to get into the math section today for SAT prep.
All right, now, so before we get into this actual section, I had actually prepared a little brief icebreaker before we start. And it's just basically, we just wanted to hear how you guys are feeling right now about this portion of the SAT, the Math with Calculator portion.
I'll go. For me, I still have got 2 years until I graduate from high school. And I guess there are a lot of math courses that I haven't checked. So I think many things will be new for me, and I try to keep track and understand some things.
Yeah, I'd say there's like a fair amount of like math in this exam, although it's not like a especially overwhelming amount, but we'll get more into it as we continue the webinar today. Anyone else have anything to add, or?
I'm bad at math. That's all you need to know. So this is kind of a review for me too.
That's fair. But yeah, if no one else will chime in, that's fine. We can actually get started now. So, I'm going to briefly explain what the SAT Math with Calculator test exactly is. It is designed, the SAT Math test, both the calculator and non-calculator portions, are designed to test students on the areas of math most important in regards to college and career success, because the kind of math that they teach here is like kind of like a baseline for what you will need to know for most colleges here in the United States. This Math with Calculator portion has a total of 38 questions. 30 of them are multiple choice, while 8 of them require you to like grid in your answer, which I'll explain shortly. These questions fall into 4 main categories, which I'll also go into in a bit. These are the heart of algebra with 19 problems in that category, 17 problems in the problem solving and data analysis field, 16 in questions in the passport to advanced math. This part covers like some more advanced topics we'll get into in a bit. And there are also some extra topics that are tested, although there's just 6 of them. And for this portion of the SAT, you will have 55 minutes to complete the 38 questions here. Yeah. So what can you expect for this exam? Well, for one, it probably doesn't necessarily need to be stated, but you must bring your own calculator to the exam. Like they will not be providing calculators during the exam, and you may not use your calculator at any other point in the exam other than the Math with Calculator section. Otherwise, you may end up being dismissed from the exam site and your scores will be canceled, as in like you won't you won't actually get any SAT score because you'll be sent out of the testing room. And also on the math with calculator portion of the SAT, you may run into problems that may be faster to solve without a calculator. And I'll get a little bit more into that later. But yeah, that's something to keep in mind. There are some problems here where you may not necessarily need a calculator. Like, yeah, I'll explain shortly, but yeah. Another thing to keep in mind for the math with calculator portion and the math section in general actually is that a formula sheet will be provided to you during this test for both portions, for both non-calculator and the calculator portions. But these formulas only really cover geometry, which is one of the subjects that I talked about in the previous slide about the additional topics in math. Geometry could be one of those questions. So this formula sheet will help you solve those problems if necessary. Oh, good afternoon, Carolina. It's okay. Yeah. But yes, briefly here, you can see the formula sheet. This is the formula sheet that you will be given for the math portion of the exam. It basically just covers things like area of 2D shapes, volume of 3D shapes, and certain special right triangles for the sake of trigonometry, which I'll explain a bit more later. And it also has some things to keep in mind at the bottom, like the number of degrees in a circle of an arc in a circle is 360. The number of radians in a circle is 2 pi, and the sum of the measures of in degrees of the angles of any given triangle, such as this one, is 180 degrees. Those are just some properties mainly concerning trigonometry that may be of help later in this portion of the exam. But yeah, most problems will not actually involve many of these. It's just, but these will just be here to help you in case you run into like a geometry problem. So you'll be able to consult these for help. But yeah. Oh yes, and also for some questions, specifically 8 of them, you will need to grid it in your answer rather than select one of multiple choices. And this picture here shows how exactly you should be gridding in these answers. With this answer, you can either, it lets you bubble in a decimal point or a divide, like a fraction symbol here, as shown here for the representation of 7/12. You can bubble in 7 here, the bubble for the divider, the divider, and then 12. And that's how you can represent the answer here. And for the case of 2.5, it's just a matter of bubbling in a 2, the decimal point here, which is in the second line, and well, 5. But yeah. Now for certain fractions such as 2/3, you can represent them in multiple ways, all of which will be correct. One way is to do 2/3, which you can bubble in by just doing 2, the divider, and the 3. You can also do decimal representations, and you can choose to round or not round for your answer here in the case of the 2/3, because it's a repeating decimal of 0.66666 and so on. But you only get 4 squares to fill in. So in this case, one way you can fill it in is by putting the decimal point at the start and 6s. Or you can also choose to round, like here it's done 0.667. Chances are when you have one of these gridded like questions that require you to grid an answer, there may be more decimal places than spaces in the grid, in which and for that you will need to round your answer. Another thing to keep in mind, if you have an answer that doesn't take up all 4 spaces, you can put it pretty much anywhere, and you can put it anywhere in the 4 squares and it will be fine. Like here you can see 201 put here on the right, and here 201 put on the left, both of which will be correct. And yeah, and as you can see here, it says columns you don't need to use for your answer should be left blank. So like if you have 2.1, 201, you don't need to put like a decimal point to indicate that that's it. It's just, that's all you need, 201. Yeah. So if you don't need to use all 4 of the squares, then you just leave whatever you don't use blank. That's all. By the way, if you guys have any questions throughout this presentation, feel free to like go ahead and ask. I'll be here to answer them to the best of my ability, as well as Danielle. But yeah, any questions so far on the format of this exam? All right. Yeah, with that, I will continue on then. Oh, wait. Stefania was asking, is needed any type of special calculator? I was just going to get into that actually. So, as you can see here, the only calculators allowed for this exam are most graphing calculators, all scientific calculators, and all four function calculators, the kind that you might see in like restaurants that just have the addition, subtraction, multiplication, and division. But that's not really recommended because there's more advanced stuff you will need to do on the SAT, on this portion of the SAT exam, of the SAT. So having a 4-function calculator may not be the best thing to bring for this exam. Something to keep in mind though is that other devices such as computers or any smart calculators that have any kind of like internet or Bluetooth connectivity functions or anything else, any other features like that you could find on a smartphone in regards to like connectivity are not allowed on the SAT. If you want a list of all the calculators that you can use, you can visit this link right here, bit.ly/SAT calc-pol, as in like calculator policy. Yeah, you can see that if you want to see all the calculators that they allow specifically. Now, I recommend either the TI-84 plus graphing calculator for the SAT or the TI-89 titanium calculator. These are the ones that I've personally used both in like SAT as well as like in my higher level math classes in general, and they're pretty solid calculators to have. And they're actually one of the ones that my classes were recommending and also recommending for the SAT. So these are my personal recommendations. If you are looking for a calculator for this exam, I recommend either one of these models. Both will work for the exam. Yeah. Any questions on this? If not, we can continue. Yeah, let's do that. Here we have, I've listed some extra resources to help with studying and preparing for the SAT with math, with calculator, as well as SAT without calculator. These have, oh, can I use the same calculator on the ACT and on the SAT? I do believe, I feel like if you have like a normal graphing calculator, like the ones that I recommended, like the TI-84 or the TI-89 titanium, you probably should be able to, although I haven't actually taken the SAT, but I believe Danielle could advise on that further. Yeah, this is mainly with the SAT, so I'm not familiar with the ACT, but yeah, I imagine that it would be similar. If not, to be safe though, you could probably also look up the ACT calculator policy to see like what exactly they allow and what they don't allow. But yeah. But anyways, I've listed here several resources that will be of great help in preparing for the SAT math portions. The primary one I have listed here, the first one is Khan Academy. Khan Academy is free resource for it provides video lessons and practice on all the portions of the SAT, including the reading and writing, as well as the math portions, both with and without calculator. The courses are free, and you can just visit the link here, and you can look for the SAT preparation materials they have. Another resource that will also be of particular importance is the College Board website, because the College Board actually offers several different practice exams for you. I believe there's at least like 10 different exams that you can download. So what you could do is you can download these exams and time yourself. Like if you wanted to practice the SAT with math with calculator, you could go to that section of the SAT, set up a timer for 55 minutes, and like try and take it as if it were a real test and see how you do with your answers. And you can also do the entire SAT practice exam in one sitting, just being sure to time yourself for each of the sections as well. But yeah, the College Board has several of those practice tests, so that those would also be good to give a try. Now, I feel like I believe Danielle could better advise on these next three resources, as I haven't gotten to use these as much.
Yeah, so Princeton Review, Kaplan, and Prep Scholar all have like free resources, though highly recommend College Board and Khan Academy as your first options. The Princeton Review, Kaplan, and Prep Scholar, they do charge for like their own little book series that you can buy, and like, but you don't necessarily need to buy anything. So you can always just look to get practice tests from Khan Academy, have like your own personalized study track on things you want to focus on. And then College Board just has your, endless supply of practice tests. So if you use Princeton Review, Kaplan, Prep Scholar, just don't feel pressured to pay for like their advising services, because in my opinion, like the same progress you meet with like your own self-study, if you're disciplined, is like the equivalent of what you'd get from them. It's just a structure and you don't have to pay for it. So just recommend the first two. The other three are just like occasional free resources that you can use online.
Yeah, personally, I've primarily made some use of like Khan Academy and the practice exams on College Board, so I highly recommend those if you want to like practice more for the exam. But yeah, let's move on. So let's get into the different areas of math that will be like tested on this part of the exam. The first one here is the heart of algebra, and well, for each of these topics, I'm gonna go more into detail on them as we continue, but I'm just gonna give a brief rundown of them right here. So for the heart of algebra, it's primarily focusing on like linear equations, solving systems of linear equations and functions. These kinds of questions generally ask you to create equations representing some situation, solving equations and systems of equations, and making connections between different like representations of linear relationships, like stuff like direct correlations and stuff like that. Now, the problem solving and data analysis includes using ratios, percentages, and proportional reasoning to solve problems in real world situations, including science, social science, and other contexts. It also includes describing relationships shown graphically and analyzing statistical data. So like for these kinds of questions, you might be presented with like some table of data or a graph, and you'll be asked some questions based on that. The passport to advanced math, like I mentioned earlier, this is the subset of questions that deal with like the more difficult, higher level math topics. These are the kinds. This focuses on the math you will need to pursue further study in a discipline such as science or economics, and for career opportunities in STEM. And so it requires familiarity with more complex equations or functions, and it will help you which is meant to prepare you for calculus and other advanced courses in statistics. And for the additional topics, it can generally include topics like geometry, trigonometry, dealing with like right triangles and all sorts of and that kind of thing. the radian measure and complex numbers. But yeah. I'll give a brief run. I'll give a rundown of these more in these coming slides. Yeah. So for the heart of algebra, like I said, this expects you to know how to work with linear equations, expressions, inequalities in one or two variables, as well as like graphs of linear equations. And I'll be showing examples of these for you to try and answer as well. So, and I'll explain them if anyone's confused. So here's an example of a kind of question involving solving a set of linear equations here. The question's asking, what is the solution x, y to the system of equations above? It's basically asking you to solve for x and y given these two equations. Yeah. Now I want you guys to try and take have a try at solving this equation and giving your answer. And I'll help advise on it for anyone else for anyone that's like confused or gets it wrong.
I think you can kind of work out the problem and then we can convene together and then talk about, I don't know, George, what you wanted to do.
Yeah, that was a general idea of what I had for this. Yeah.
Okay, cool. I'm gonna work on it too. Let's see if I get it right. It'd be really embarrassing if I was a UChicago student and I didn't know how to do basic algebra. You guys are smart.
Yeah. Yeah. So if there's anyone confused about this kind of problem, just let me know and I can like help it going over it and how to like work it out. All right, has everyone gotten it or do they need any more time? Or like are you confused about anything? Yeah, Type, what you're saying, yeah, I will either, regardless of, I will explain like a brief bit, like how I, ways to do it, and as well as like how I did it. But yeah, um, I think I'm gonna give this a little bit more, give a little bit more time before I like go over how I did, like how I did this and how you could approach this. But yeah, Daniel's right. There's different ways to approach this kind of problem.
You can be a nerd like me and just copy what everyone else is saying and then just plug it into the equation. Kidding, kidding. I worked it out a few ways.
I will say though, like the way she was talking, like I would not I would not really recommend trying to like
It takes too long.
plug in answers to the equation and try and see which one works. Oh, that. Yeah, I would not recommend that. It would take too long for you to do. It's better to try to just work it out. And
To be
get the
fair
solution.
though, you could be fast. Like, I mean, you could, because I feel like for this equation, you could plug and chug at a reasonably similar time as to like if you did like elimination, you know.
It's a matter of habit though, because
Right, because you want to actually know what it is.
you want to know
Because you
what it
keep
is,
getting the problem.
and
Exactly.
chances are there will be other problems that you won't be able to do the substitution as easily,
That's
or it'll
true.
take longer. So yeah, it's just a matter of principle to know how to like, or to work these problems out rather than just try and check, guess and check.
Plug and chug is for like only for problems where you like just genuinely don't know like what to do. But like,
Yeah, and even then sometimes, and then even then, generally you're not going to have like problems that actually do that like could work like that necessarily. This is mainly for like the heart of algebra set. This is for the heart of algebra. So
yeah, so don't plug and chug. You gotta actually know a majority of how the stuff works.
yeah, but yeah, I think I could, yeah, I could probably just briefly explain what I did for this. Maybe show, maybe get to like whiteboard it a bit. I'm just trying to see how to do that exactly. I think maybe I have to pause my screen. We just pause my sharing of the screen. We just note something real quick. Okay, I'm just going to pause sharing for a bit and actually I think I have to just stop it. So let me see this. Okay, I cannot seem to get the whiteboard. I don't see it. So I'm just, what I'm going to do instead is, here, just 1 sec. I'm going to try and
I can look it up. I
Like the-
could have sworn there was like a whiteboard function on Zoom.
yeah, that's why I'm confused.
Wait, I got it. Hold up. Let me test this out. Let me see how big brain I am. I am not big brain, never mind.
Okay, I think what I can do is I can share this other website for a whiteboard. Might as well do that. So we start with the original equation, which was like 6x plus 3y equals 33, and 6x minus y equals 5. So looking at this, there's 2 ways to go about solving this, one of which is much easier to do thanks to the presence of the 6x in both of the terms, in both of the equations. And the strategy I'm talking about here, the first one is to subtract one of the equations from the other. So like what we're going to do here is you're basically going to subtract 6x from 6x minus y from 3y and 5 from 33 to get a combined equation here. So what happens here is that these cancel out, so they're nothing. When you negate a negative number for subtraction, it becomes addition. So you get 3y minus negative y, which means like plus y. So you get 4y rather than, yeah. And 33 minus 5, that's 28. And from here, you can just solve for y, which we get as 7. And from here, you can just plug in y into one of the other equations to solve for x. So like when you plug in y here, like in this simple equation, 6x minus y equals 5, you get 6x equals, or 6x minus 7 equals 5, 6x equals 12, and then x is 2. And that's how you get the answer B. So that's one way of going about it, the easier way for this particular question. But there's another way to keep in mind, which I'll also go over briefly. Another way you could do it. It's a bit more complicated, but sometimes you'll have to solve the equations this way if you end up if you don't end up with something like this where there's a common term in both equations. And that involves solving one of the variables in one of the equations. So here you can see like y is simple. So what you can do is you can like try and solve for y in this bottom equation. So you get y negative y equals 5 minus 6x. And then you solve for y in terms of x. And then what you do is you plug this into the first equation or whichever other equation is left. And from there you can evaluate it. And yeah, I'm not sure. I don't think I'll write this out because it'll take me a while. But yeah, once you plug this y in here, once you plug this y term here in this equation, you'll get another equation that consists only of x. And from there you can solve for x and get the same solution. But yeah, the first one I was talking about, that's the easier way to go when you see two common terms like this. So yeah, let's continue now. Are there any questions about this, by the way, before I continue? If not, then I can go ahead. I'll go ahead and continue here with inequalities. This one's simple enough. This one, I see what Danielle's talking about in regards to like plug and chug. This is probably one where you could do that. Although, again, I wouldn't exactly recommend it. But yeah, this is kind of, yeah. So yeah, go ahead and give this a try, everyone.
Bro, it hasn't even been like a full minute. Somebody already solved it.
Nice.
Felt different.
Yeah. If there's any, I don't think I'll give as much time for this because it's a bit simpler than that other systems of equations. But yeah, if there are any questions so far, just yeah, let me know. I think I'll explain this one now. But yeah, for the people in the chat and those who haven't answered yet, the answer is indeed A. So yeah, let me just go ahead and explain that real quick. Yeah. Okay. Yeah, this has to load again. So this question is oh wait, it's in the chat. When we say that x is bigger than -2, why does it go to the negative numbers instead of the positive ones? I'll demonstrate this as I solve it real quick. I'll show you here because yeah. Yeah, let me just write this out real quick. So this is basically, it's kind of not it's not that different from solving a typical algebra equation. The only difference is it's an inequality. So yeah, let me just get into that real quick here. And what you end up here is -2 is greater than or equal to x, which you can then invert as, you can flip it around for easier readability as x is less than or equal to -2. So the solution here is actually x is less than or equal to -2, not bigger than 2. So what's happening here is that in the original question, it was asking which value of x is not a correct solution of the inequality. So like as you can see here, it's asking, it shows a series of options asking which one's not a solution, like which one's incorrect if you substituted it for x. And based on the answer here, x is less than or equal to -2. That rules out B, C, and D because those are all less than or equal to -2. B is like they're equal, so it fits the inequality. -3 and -5 are both less than -2, but -1 is greater than -2, so it's not a correct solution, and that's the answer for the question. That's another thing to watch out for when it comes to these questions. Sometimes you'll see questions asking for what something is not, like it's asking you which number does not fit some, like I don't know, like maybe it'll ask like which is not like, so maybe it'll be something like this, which is not a solution to the problem. You'll probably see some of those in the SAT. I remember having seen some of those, but yeah. It's very important to pay attention to the wording of the question because they might try. What might also happen is they might ask like a sort of trick question and be tricky in their wording. So it's important to pay attention to what specifically it's asking for. So in this case, it was asking for the number that isn't a solution of the presented inequality. But yeah. I hope that I was able to answer your question, Catalina. If there are any others, just go ahead and ask. All right, I think I'll move on then. Now this one's a bit trickier. This one presents a graph and it's asking for the correct equation of the line for it. And yeah, go ahead and give this a try and we'll go over it as well.
Built different. I got it.
Is there any confusion in solving this, or is everyone good? If there's any confusion, just go ahead. Just yeah, all right. Just making sure, because I'll be going over this in a bit for those that may be confused or such. But yeah. Yeah, I'll explain it in a bit, Elizabeth. Don't worry. All right. I think I'll explain this problem now. So let me just pull up the whiteboard real quick. Yeah. So the for this problem, a graph was presented. Yeah, X, Y. And it looked something like this. Just ignore this rudimentary line drawing, basically. Let's see if I actually get it right. Perfect. So yeah, it was basically asking for the equation of this line. And yeah, so let me explain how you would find this. So the easiest way to find the equation of the line in this case, because the line that's the graph of the line that's being shown to you passes through the y-axis, the easiest way to find the equation of this line is to use the slope-intercept form. With the slope-intercept form, you might have seen this, but it comes in the form of y equals mx plus b. M here refers to a slope, which I'll explain in a bit, and b refers to the y-intercept. This is what the equation will equal when x is 0, so when it's on the y-axis. So for this, so the way slope works, it operates on the principle of rise over run. And what this means is basically it's basically asking for like the change in the y value here over the change in x. So in this case, let's look here. So when x is 0, y is 3. Yes, you see that here. That's this point. When x is 0, y is 3. That's what this means. X is 0, y is 3. And then when y is 0 here, we see that x is 2. So we get 2, 0. So what you want to do is you want to subtract these coordinates from this one here. So you would put the y value, you would put these y values, or like you would put the y values, the 3 and the 0 on the top, and you would put the x values in the bottom. So like, let me show you what I mean by here, by like subtracting here. So the rise, remember, it talks about the y-axis, like up and down here. So that would be 0 minus 3 for that. And for the run, which is the horizontal movement, that would be 2 minus 0. So that gives us a slope of -3 over 2. And this is what goes in the m of the final equation. Now, as I mentioned before, the b represents the y-intercept, meaning when x is 0, the value of this function here, this equation, will be whatever b is. to figure out B using this graph, all you have to do is just look at what the Y value is when X is 0. Like, what is it on this line? And as you can see, as I pointed out earlier, it's 3. Y is 3 when X is 0. So that means B has to equal 3. So the final equation comes out to Y equals -3 over 2 times X plus 3. And you can see it here. Like if I plug in 0 for X, this whole term becomes like 0. It like effectively doesn't exist. And all that's left is the 3. So that's how it ends up as 3 here on the graph. Likewise, if you were to plug in 2 into this equation, you would get -3 over 2 times 2, which is just -3 plus 3 is 0. And that you see that point again here. So that's the power of the slope intercept form. Given 2 points of a line, you can calculate any 2 points of a line, you can calculate the slope, its slope, and you can use that in writing to write the equation of the line. Yeah. Are there any questions about this?
Can I bring up something really quick too?
Yeah, go ahead.
So I feel like you don't necessarily have to do like, well, okay, this is good so you understand the concept of rise and run for slope, but just some general rules, right? So just looking at the graph itself, if you want to solve it a little faster, it's a negative graph, so you can automatically like cross out any options that were positive. I think D was like the only one that like showed it was a positive slope, but it's not a positive slope. If it's going down like this, that's a negative. If it's going up like this, that's a positive.
Your camera is mirrored actually, so
It
it's
is?
showing the yeah, it was showing the
Oh.
opposite.
Okay, well, look at the graph. That
Yeah,
is the example of a negative slope. And then if you flip it, like, okay, so that's negative, what
yeah.
George just drew. And then you can automatically cross off the options that aren't like the positive slope. And then the other way is the positive. So if it's going like what George is drawing. So, and then generally, yeah, do rise and run. And then just where, if you want to single out the y-intercepts quicker, just see where the slope like intersects on the y line. And then you'll identify just quickly like what the y-intercept is. So just from looking at it, you can kind of tell, okay, it's negative. So it's one of A through C. And then if it intersects at +3 on the y line, then you can cross off the ones that had like +2 or -2 or whatever. So if you want to like quickly know how to read graphs, that's just kind of my 2 cents.
Yeah, thank you for that. I was actually meaning to bring up like the negative and positive slope thing is like a sort of shortcut, but I forgot to. But yeah, thank you for that. So yeah, let me see the chat. Yeah, of course, I forgot this was helpful. So let me continue now. Yeah. So those kinds of problems, those are the kinds of problems that you'll see on the SAT. They'll usually involve like equations or inequalities of like one variable, or in the case of the sets of systems, you'll get like 2 variables maybe, and they'll pretty much always be like of degree 1. So you're not going to see like anything quadratic like an x squared or y squared or anything like that for these kinds of problems. That comes later, but for now, the next section I will go over the kinds of problems you'll see is the problem solving and data analysis. As I mentioned before, this type of problem expects you to be able to read and analyze data presented in either like a table or graph form, as well as understanding ratios, rates, and percentages. Now, just like in the reading portion, as if you may remember from the previous SAT prep session, you are not expected to know about the exact material that the data is about. Like if the data is about like maybe, I don't know, like population growth or population change, you're not expected to know about that. You just have to know how to read and understand the numerical information that is presented and be able to identify trends with the data. So yeah. So here's 2 problems involving this chart here, or this table here, of annual budgets across the years in Kansas. So yeah, give those a try. And we'll convene in a bit.
Is there a way you could like zoom in a little bit on it?
I don't think so. I can just grow. I can just like increase the size of it. Like, let me see. Let me know if this is any better. Is it?
Yeah, like a little bit.
Alright.
Data analytics.
I don't know if you're trying to speak, but your mic was quiet. That's right. Are there any questions or confusions about this problem, or is everyone good? Because I'm just wondering so I can like go and explain. Type, it's okay if you're unsure. I'll explain like how to read this, how to best read this for these problems. So yeah. All right, I think I will go ahead and explain it then. So let me just do that real quick. So first, let me just see if I can copy this here, because if I can, that'd be good. Let me try that again. All right, so I'm just gonna bring this graph over here again. Now, let me explain 22 here. So remember how I was talking about the slope earlier for that graph problem? This is for number 20, problem 22 here. It's actually another like example of that sort of thing. Another way to think of slope is the rate of change. And that's what it's asking about here. So it's asking for the best approximation of the average rate of change in the annual budget from the agriculture and natural resources in Kansas from 2008. So that's the first number we need to know, and to 2010, and that's the second one. So you can treat the year and the budget here as like a sort of point, like it's on a graph, the same way I was talking about earlier. So you could think of it as like 2008 and like 358K or something like thousand. And same thing with the 2010 data point. And that's like 488K. So the way you work this out is like a sort of rate, it's a rate of change. So you want to see how the change, like how much it changed per year from 2008 to 2010. You do it the same way you would do the slope problem, the rise over the run, the rise being the change in the prices and the run being the amount of time elapsed. So it would look something like this: 488. For simplicity, for the sake of simplicity, I'm just focusing on the thousands here because the small numbers are very minuscule and they're not, it's asking for an approximation. It's not asking for the exact thing. So working with these will make it much easier to read and calculate. So we have 488,000 minus 358,000 over, well, the years. You don't have to write this out necessarily. As you practice this kind of problem more, it'll become more intuitive that it should be just like this thing over 2 years and, well, this. So what you end up with here is 130,000 over 2 years, because this is the unit here is like years, and that's what happens here. And this is the budget. Yes, Taib got it right. It's the correct answer based on what I just wrote here. The correct answer then becomes 65 million. I was talking about thousands here, but I forgot that this. Another thing to keep in mind with these graphs is sometimes it'll present information in a condensed way. And as you can see in this tagline here, it says the table above lists the annual budget in thousands of dollars. So these actually represent like 358 million and stuff like that. So that's something to keep in mind when you're doing these calculations. So as you can see, like I was working with the thousands here and I got 65, but that in itself is already a clipping of 1,000. So 65. So it's actually supposed to be 65,000, but then based on this here, it's actually 1,000. So that's how it evaluates to 65 million. Sorry if that's a little confusing, but yeah, this is just how I would work it out in my head and how it should probably be best thought of for this sort of thing. But yeah, okay, let me explain number 23 then. This one seems a little more complicated, but there's actually an easier way. There's actually an easy way to look at it. So hold on, let me just erase this real quick. Yeah. So, okay. So this question's asking which program's ratio of its 2007 budget to its 2010 budget is closest to the human resource program's ratio of its 2007 budget. So it's asking for the budget for human resource in 2007 to 2010. Are we? Yeah, okay. So you can see here, like these are big numbers. Trying to calculate the actual ratio of these numbers is going to be pretty difficult and kind of pointless to do with a calculator. But there's an easy trick for this. And the trick here is to work with exclusively the millions digit here. So you can see here for like this human resources in 2007, the most significant digit here is like the 4. The 4 is like the most prominent because you can see this 51,000. It's pretty it's like marginally relevant to this problem because it's asking for a ratio. So like you don't really need to focus on that. And likewise, you can see here for 2010, it's like 5,900,000. And for the sake of simplicity, you can treat this as if it were 6 million actually. Oh, okay. See you then, Hector. For the sake of simplicity, see, given that it's 5,900,000, yeah, I'm getting to that. But I was just gonna say, this can be treated almost like 6 million. And from there, when you do a ratio from 2007 to 2010, you get like 4 million to 6 million. And what does that get? What do you get from that? It's about 2/2 to 3. Yeah. So from there, you can apply the same trick of like focusing on the biggest, the biggest digit, like the millions digit, and the other categories, the other programs that here to figure out which one has the closest ratio. So let's look at the examples here. For agricultural natural resources, this one only has thousands, but you can see the biggest unit digit here is the 100,000, which is 3 in 2007, and in 2010 it's 4. So the approximate ratio would probably be something like 3/4. So that's not very close to 2/3. When we look at education, this one has the millions digit again, and you can see it's 2 for in 2007 and 3 in 2010, and we get 2/3. Let's just look at the others real quick to be sure about this one, because this is like, well, pretty close to the other one. Highways and transportation. This one, it's a bit more difficult because it's a bit weirder, but we can see that it's probably not the answer because both of the millions digits are the same. So the ratio will be like comparatively smaller than this, or like weird in that way because of this. And public safety, we get the same thing again. 2 and 4. When you put those over one another, you get a ratio of like about 1 to 2. So yeah, as you can see, the closest answer to what we're trying to find is education, which has like an approximate ratio of like 2 to 3, just like the human resources. So the correct answer is B in this case. I know it's probably a bit much to take in, but if anyone has any questions, just let me know and I'll move on to the next set. All right, if not, then I will continue on then. Okay, so this one focuses primarily on percentages. So give this a problem, just give this problem a try and I'll explain it afterwards. Are there any questions about this far, or are people good? Yeah, again, is anyone confused? Because if if you guys are confused, I can explain this problem. Because the wording might be a bit tricky. So yeah, okay. Yeah, Carolina, I'll explain it. Yeah. Um, yeah, I think this one's a bit is a bit tougher than the others in regards to its wording. So I will go ahead and explain it. Let me just copy this and put it here. Okay, so let's read read this carefully and see what's happening. So Alma bought a laptop computer at a store that gave a 20% discount off its original price. So discounts, as you may know, they're like deductions from like the full price in a percentage. So we have the full price, like a full price of something, like without any changes, it's 100%. But when it's subtracting, when there's a 20% discount, you're subtracting from this 100%. So you just have, you take that off, and then what you end up with is paying 80% of the full price. And 80% in decimal form, since percentages are divided by 100, you get 0.8. This is something we're going to need in a bit, but that's what the meaning, that's how the discounts should be interpreted. So next it says the total amount she paid to the cashier was $P. P here is supposed to be the final value of what she paid, because it says here, including an 8% sales tax on the discounted price. So this is the final value. This is not the original like price or anything she paid. But before we get into how to figure out the original price in terms of P, we need to understand the 8% sales tax. So the same principle as what I mentioned with the discount applies, except you're adding a percentage to it. So there's an 8% sales tax, 8% sales tax. So what you end up paying is 108% of the original price, or like whatever quantity you're talking about here. So in decimal form, that becomes 1.08. So since P is it's the final price after everything, that means we don't know what the original price was. And we can treat this as we can express this original price as some variable. We can just do X. X represents the original price. So the problem mentions that Alma bought the laptop computer at a 20% discount, which means, so we can write that as X times 0.8, just like I mentioned earlier with the 80% like full price. And then it says that she paid an 8% sales tax on the discounted price. All this really means though is that given this original quantity, we can we can just let's surround this in parentheses for like the sake of clarity. That means given this price, you have to multiply by 1.08 to indicate that you're paying 100%, 108% of the discounted price here. And that all this is equal to P. So to solve this equation, what you end up doing is you divide these numbers on both sides to isolate X. So what ends up happening is you get X equals P over 1.08 and then multiplied by 0.8 at the bottom again. And so therefore the answer here is D. Does anyone have any questions about this in regarding to like interpreting discounts or markups like taxes? All right, glad you got it. I'm glad you got it, Carolina. Anyone else have anything? All right, if not, then I will go back to this. So yeah, these kinds of percentages, these are the kinds of things, these percentages and ratios, as well as the data now, like analyzing a table or a graph, like a pie chart or something like that, or a line graph. Those are the kinds of problems you'll tend to see in the problem solving and data analysis portion. But yeah, moving on, we have the Passport to Advanced Math set of questions. This question deals with the more difficult topics, particularly those that are like covered in Algebra 2. And these include topics such as quadratic equations, nonlinear graphs, exponents, radicals, and other functions like logarithms. So yeah, let's get into a bit of that. So quadratic equations here, I'm just going to give a brief rundown. They generally come in the form of A, which is some constant number, times x squared plus B times x plus C equals 0. Those A, B, and C are all different numbers. They can be, they can be anything. Sometimes they can be 0. And when they're 0, well, A can't be 0 because if A is 0, then it's no longer a quadratic equation, but B and C can be 0. But yeah, quadratic equations can also come in factored form, such as x minus n in parentheses times x minus m in parentheses equals 0. So there, and generally what you may need to do with these kinds of problems involving these equations is finding the solutions to x for these quadratic equations. There exist strategies to solve the quadratic equations through factoring, but not all of them can be factored. Factoring is a strategy of like trying to get this ax squared plus bx plus c equation into the form of x minus n times x minus m. Because in this form, the solution to the equation is just n and m. X equals n or m. If x is either one of those values, then the equation is true. So those are the solutions. So that's generally something you would want to do when you see an equation of this form and you have to solve for x. You want to try and factor it like this. I'm not going to go over exactly how to factor this sort of thing because that's information you can find by practicing on Khan Academy or on other online resources. But there is also a formula for solving any quadratic equation of the form ax squared plus bx plus c equals 0, as I mentioned before, and it's this thing right here. So the solution becomes x equals negative b plus or minus the square root of b squared minus 4 times a times c, with all that divided by 2a. The plus or minus here means that there's two solutions. One of them involves you adding negative b plus the square root, and one of them is negative b minus the square root. So that's the quadratic form. That's the quadratic formula that will come in handy in case you cannot factor this and figure out the solution with that for whatever reason. Maybe it's just slightly off from being factorable or something like that. But yeah, this is a formula to keep in mind, because even if you forget how to factor something, you can just plug it into this formula and be good to go. Are there any questions about this? All right, if not, then I will go ahead and continue. Oh, okay. Yep. All right, Carolina, let's move on. Now, another thing you may need to, you may end up encountering in this section is nonlinear graphs, which include graphs of functions such as exponential, logarithmic, radical, and rational functions, as well as polynomial functions of degree 2 or greater. So you can see in order here, we have an exponential function, specifically f of x is equal to 2 to the power of x. In this graph, and as you can see, there's the graph here for it. You may be asked to like analyze some property of this graph, of graphs like these for this. And likewise, there's also the inverse function of an exponential. Here we have f of x is the logarithm of base 2 of x. It's basically the inverse function of the exponential. The problem it solves here is basically what y represents the f of x represents the exponent necessary. Let me think about how to word this. It's basically what exponent is needed so that you can raise to such that raising 2 to this exponent will result in x. So like you can see, when x is 1, the logarithm is, the value ends up as 0. That's true for any logarithmic function, because any number except 0, when raised to the power of 0, is equal to 1. And that's the principle. That's the same thing that's in principle here. That's in place with this. When x is 1, the logarithmic function will always be 0. Now, another type of graph you may encounter is a rational function, which involves the division of two polynomials generally. Here we have the equation here is x plus 1 divided by x squared plus x, which means whenever the denominator equals 0, the function will be undefined, and it may have asymptotic behavior like this, where both sides approach positive or negative infinity, depending on which side it is. So like on the positive side, as it approaches 0, it approaches positive infinity, but on the left side, where values are negative, it approaches negative infinity, because as these values approach 0, they're getting very small, which means the division, when you divide a number by something very small, the result is very, very large. So it approaches infinity that way. And the last type here is just a simple quadratic equation, which is a type of polynomial. It's here, it's y equals x squared minus x minus 2. And it's just a graph here. And you know it's a quadratic equation because it takes on a parabola shape like this. Yeah. And yeah, that's generally a good indicator of a function being quadratic if it takes on a parabola shape like this. But yeah, let's move on. Any question? Actually, are there any questions about these kinds of graphs? If not, we can continue. Yeah, I'll go ahead and do that. Yeah, the other thing to keep in mind for this kind of portion are working with exponents and radicals, like such things simple such as like the square root, but for any sort of n root. So like it could be like a cubic root, a quadratic root, or something like that. But you may need to make use of exponential and radical properties to solve certain equations. So I want you guys to try doing this problem here on the left. This doesn't have the solution. The writing here isn't the solution, but it's one of the steps you can take to try and solve the problem, which is if 2 raised to the power of x plus 3 minus 2 to the x is equal to k times 2 to the x, what is the value of k? I'll let you guys give that a try. If there's any confusion about it, though, please let me know, because this is a bit of a trickier problem. So.
Como estas grandototas, yo creo que las puedo poner acá. Como las teníamos. Ay, Dios. Yo creo que voy a acabar pidiendo una pizza. Un cáncer. Y todavía me falta tener están las ollas. No las puedo dejar así.
Are there any other questions about this? Because if not, then I'll go ahead and explain. If anyone needs more time, then just let me know.
Ay, cabrón. Y ¿dónde quedó esto?
Para lavar.
No,
Ya está.
para cañones.
Ok.
Analia, I just wanted to let you know that I muted you for now. I don't know if you were intending to speak, but if you are, you can go ahead and unmute. But yeah, I think I will go ahead and explain this problem though. So let's get to the whiteboard real quick. Yeah, just one moment. Yeah, just one moment. Okay. Oh, wait, I was looking in the chat. Oh, you're struggling, Carolina? That's okay. I'll explain it. So, well, so we are given an equation here, 2x plus 3 minus 2x, 2 to the x equals k times 2 to the x. Now, the important thing to note here is that it's not asking you to solve for k, x. Rather, it's asking you to solve for k. So for all intents and purposes, the x, like the value 2 to the x, we can effectively treat it as like a constant value, like the way you would treat like 2, 3, or any numerical value that doesn't have like a variable, like some variable potential fit, because the x is irrelevant. The x is, it's not particularly relevant to figuring out what k is, but we will see how this works. So a property, so to figure out how to go about this, we can remember a property of exponents here, namely when we have an exponent a raised to the power of x plus y, you can write this out as a to the x times a to the y. And that's what you're going to want to do here with this 2x to the x plus 3. You're going to want to write it as 2 to the x times 2 to the 3 to the third power minus 2 to the x power, and then we have the right side the same, which is k times 2 to the x. Now 2 to the third power, if you evaluate it, maybe you can already see that it just equals 8. So what you end up here, let me just erase this real quick. Rather, let me move it down like here. What you end up seeing here is that since this is 8, what you have essentially is 8 times 2 to the x minus 2 to the x equals k times 2 to the x. And what ends up happening here is 2 to the x, it's effectively just like let's say like a dummy variable, like it doesn't have any particular significance, but the main thing is these are like terms, and because they're like terms, what I mean here is that, like, let's say you have like something like 7x plus 3y minus 4x. When someone says to combine like terms, what they mean is try and simplify the terms that have the same like coefficient here, like the x or the y. In this case, only these two here can be simplified. So 7x minus 4x, that's 3x, and the 3y is just left alone. And that's combining like terms here. The similar thing happens here in the case of 2 to the x, which is essentially just it's just an empty coefficient. But what matters is that they have the same coefficient, 8 times 2 to the x minus 1 times 2 to the x. So you can effectively subtract these without issue. And what you end up with here is 7 times 2 to the x equals k times 2 to the x. And then from there, you can just cancel out the 2 to the x terms, and you end up with the solution here, which is k equals 7. That might be a bit confusing, so if there's any questions about it, please let me know. Okay, if there's no other questions about this, then we can go ahead and move on. So I'll do just that. But yeah, another thing to, oh wait. Okay, yeah. Yeah, good job. Good job, Taib. I wanted to mention that because you got it like before the explanation too. So good job. Also on this slide are some exponent rules and radical rules, as in stuff like square roots, cubic roots, or whatever. That's what the n is supposed to represent. Square roots normally don't have an n written, any number written here. It's if there's no number written, it's implied to mean a square root. But if there's a number there, then it explicitly means that root, such as like cubic root, quartic root, like for 4 and stuff. But yeah, you can take a picture of these rules if you need, but they're also, you can also find them online by searching for exponent rules, radical rules, and there's another set of rules to learn as well for logarithmic functions, which you can also search online because they're pretty similar to the exponent rules. But yeah, let's move on. Here, there's also additional topics in math, which I'll briefly go over because there's not as much to it, and there's only about 8 or 6 problems for you to do on the actual test. But this kind of question covers other math topics not presented in that previously, the kinds that I was showing, like algebra or complex math. This generally includes problems about geometry, trigonometry, and angles. So the geometry portion, I already mentioned earlier that you'll be given a formula sheet for assistance in solving the area or volume of some shape, such as like a sphere, cone, or the area of like a circle and stuff like that. They give you a formula sheet. For trigonometry is it's the field of math concerning triangles. And three of the most important functions, in case you haven't heard of them already, are known as sine, cosine, and tangent. And these are functions that concern a right triangle and an angle of the right triangle. This theta here, this theta here is never the right angle, but yeah. So for the sine of this angle theta, the value is calculated as the side that is the length of the side that's opposite of this angle here over the hypotenuse being the longest side of the triangle, which is always the one that's opposite the right angle here. So sine of theta here is the opposite side, the length of the opposite side over the length of the hypotenuse. For cosine, the cosine of theta, it's evaluated as the length of the side that's adjacent to the angle theta here over the length of the hypotenuse again. Now, tangent is actually it's different here because instead of involving the hypotenuse, you calculate it with the length of the opposite side here over the length of the adjacent side. Because of that, you can also express it as the sine of the same angle theta over the cosine of angle theta, and it'll be the same thing. But opposite over adjacent, that's That's the easier way to remember tangent. And here I also have rules for determining similar triangles in regards to like congruency. Congruency is referring to two triangles that have the same shape, the same size and angles. But similar triangles basically mean that they have the same angles and their sides are proportional. Meaning, like you can see for these triangles, you can see like for these triangles here, they have the same shape, but they aren't the same size. But what happens is since they're the same shape, what happens is that this triangle is proportional in size to this one. It's like you took this one and shrunk it, you end up with the other one. That's the principle of similar triangles. And there are some different rules for determining whether two triangles are similar. If they meet any of these rules, then they're similar and thus proportional. The first one here is angle. If two equivalent angles are the same or congruent to each other, in this case, it's talking about angle CAB, this one right here. This one's congruent to angle GEF in the other triangle. And if angle ABC, this other one with the angle with the two lines is congruent and equal to the other one EFG, that means these two triangles are similar. Keep in mind these angles have to be are just next to each other. That's what the rule is. The next one is side angle side, which means if the angle between two sides is the same, in this case BAC or CAB is equivalent to FAG, and the proportion of AB over EG is the same as the proportion of AC over EF, then that means they are similar triangles. Like you have to like set up like a proportion of AB's length over EG's length, and then see if the proportion set up with AC's length and EF's length is the same. If they're the same, then they're similar. And then the last one is side, 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 which is basically if the proportions of each of the sides are the same, then they're similar. In this case, AB over EF, that's one proportion. If it's equivalent to the proportion BC over FG, and also AC over EG, then they're similar. That's the principle in place here. And the angles I mentioned previously, they're on the formula sheet, but it says that the angles inside a triangle will always add up to 180 degrees, and that the angle of the longest arc in a circle is always 360 degrees. That's how many degrees it goes around, and it also goes 2 pi radians. But yeah, there's not too many of these questions, but it's still like a good idea to get a closer look, to get like a close look at like geometric and trigonometric problems for this sort of thing, like just a bit, because you'll probably run into some of these in this portion of the questions. But yeah, so here's some like advice overall for the math with calculator test. As I mentioned before, you should do practice tests, and there are many available on College Board's website, and there's a quick link to it here for those who want quick access without like having to search it up. You can just type bit.ly/SAT practice test, and it will take you to the College Board's page where they have all their practice tests available. And the next set of advice I have is to definitely practice math concepts on Khan Academy. There are resources specifically created for the SAT math portion, both the portions both with and without calculator. And it talks about the same topics that I mentioned in this presentation and more. It also gives you some various practice problems to like practice what you learn in the lectures and everything like that. So it's a very good resource for like getting like a bigger idea of what's something going to be on the exam and to practice that same material. This one, I also personally recommend to not be too over reliant on your calculator. While mental math is generally saved mostly for the SAT math without calculator portion, it's also something to keep in mind that if there's some calculation on your problem that you're trying to do that you can easily do mentally, you should do that instead of entering it into your calculator, because it will waste time. If there's something you can easily do without any issue, without like needing to like crunch the numbers, like let's say you have a simple addition or something, then you can evaluate that in your head and write it down rather than having to waste time like entering the numbers into your calculator and getting the results. If it's something you already know how to do easily, then do it. If it's something you know how to do but not as easily, then you should probably use the calculator to be sure you're doing it like correctly, the calculations and stuff. And this last piece of advice I have here is kind of a general thing, but it's especially important for the math portions of the SAT, and that if you're struggling with some problem, skip it and move on to the next, and then look back at it later. Because what happens generally is if you're stuck on a problem and keep trying to solve it over and over, or are just confused, you're going to waste a lot more time than you would by skipping the problem and working on everything else that you can work on, and then trying to use the time you have left to think about those tough problems again. So it's like good advice to just like skip a hard problem, focus on all the other problems you could get, and go back to the harder ones after you finish those, because there are more like points to be gained doing the easier problems than just being stuck on a difficult one. Yeah. If Danielle has anything else she'd like to add for this, then she can go ahead.
Yeah. Honestly, no. I think today was a pretty good review session, and good job.
All right. Yeah, that's good. Yeah. But anyways, we're approaching the end of our session now, a bit early, but it's okay. But before we leave, I wanted to also mention that we have a study group on WhatsApp, which you can join here with this link, bit.ly/study4SAT. This link is case sensitive, so you have to enter those capital letters. Just keep that in mind. But if you want to like contact any of us for questions about the SAT, like maybe you're doing a practice test, maybe you're doing like a practice test and you're going over your answers and see something's wrong, but you don't understand why, you can contact me or Danielle through this WhatsApp group. And yeah, so we recommend you join this so you can get further help with preparing for the SAT. It doesn't have to be just about the math portions. It can be about any of them, reading, writing, and so on. But yeah, I'll leave this up a little bit so that you can either type in the link or save it for joining later. But yeah, I'll leave this up for a little bit. All right. And with that, we will close off this session. But before we do, I also wanted to advertise. Oh yeah, I wanted to show. Oh wait, this date's not right. This date should be the 8th. Let me just fix that. Actually, it's supposed to be the 8th here. But on the 8th next week, on Monday, at the same time, 4 p.m. Central Time, we will be going over the math portion of the SAT without calculator. And And in case you're not registered for that event, the link to register is right here, which is bit.ly/CDMX SAT prep. So in case you're not registered for this upcoming event, then you can register at this link. But yeah, and I'll leave this up for a little bit in case you need to note down the link. Yeah, of course, Carolina. Yeah. So with that, that will be the, oh, can you share the link for the WhatsApp group to the chat, please? Oh, yes, just one moment. I will do that real quick. I have it up on the screen here too, if anyone still needs the link. Hold on. Oh yeah, Danielle got it, but mine, I have a clickable one, so there. But anyways, yeah, I'd like to thank you all for attending today, and I hope this presentation was helpful for you in your preparation and review for the SAT. And I hope you can join us for our next SAT prep meeting next week, where we'll be talking about the math without calculator portion. Thank you, everyone. You guys are dismissed.
Thank you guys for coming.
Thank you so much. Thank you so
Of
much.
course, of course.
Thank you guys. This was a special meeting. I really changed my view to this portion of the SAT, and I really appreciate those quick exercises and the help you gave us. Thank you all, and see you again.
All right, see you
Thank
soon,
you.
Taib. Thank you.
Thank you.